Good day and welcome to my next video, and today I'm going to show you how to solve a simultaneous equation using matrices. Now, let's get started on it one time. Now, on the board, you're going to see a pair of simultaneous equations. And as you may have remembered, when you're solving a simultaneous equation, you're already solving for x and you're solving for y. So at the end of the day, we have to get two values, one for x and one for y. Now, when you are using matrices to solve a simultaneous equation, the first thing you have to do is to make sure your equations are lined up properly. What I mean by that is you have to make sure the x's come first, then the y's, and the numbers without any letters has to go on the other side. And the same thing for the other equation, equation 2. Notice my x's come first, my y's come second, and the number without the letters goes on the other side of the equal sign. It's very, very important it's lined up properly, otherwise it will not work. So in a case where the x and y's are mixed up, you will need to rearrange it so it looks like this before you start the question. Now, one thing I just want to mention, look at the second equation. You see a number touching x. The number touching x is 3. But when you look at the y, you do not see a number. You're just seeing a minus sign. If you are not seeing a number, please ensure that you write in the number 1. Physically write in the 1. If you do not write in the 1, you may make the mistake and think the number is 0, but it's actually 1. So what we're going to do now is take this simultaneous equation and convert it into a matrix. When you're doing this, you're going to write one big matrix followed by a small matrix, an equal sign, and another small matrix. The big matrix is actually a 2 by 2 matrix. The small matrix here is actually a 2 by 1 matrix, and the one on the end after the equal sign is also a 2 by 1 matrix. What we're going to do, we're going to take this simultaneous equation and throw it into these 3 brackets. Here's what we're going to do. The numbers touching here are 4, 3, 3, and minus 1. We're going to take the numbers, don't forget the signs, we're going to take the numbers, extract them, and put it in the big brackets. So we're going to put them in the same order. 4, 3, 3, and 1. Notice I made one slight mistake. This number here is not supposed to be 1. The number touching y is actually minus 1. So it's a very common mistake to forget out the minus sign sometimes. Be very careful. If it's negative, put in the negative. In the second brackets, we're going to put 2 letters. You all notice that x comes before y. Because the x comes first, we put it on top. And because the y comes second, we put it underneath. So, x first goes on top, y second goes underneath. By now, you may have figured out the 2 numbers that go here will be 47 and 90. Now, the aim of a simultaneous equation is to solve for x and y. Now, let me put something forward to you. Let's say we had a very simple equation like this. X plus 1 is equal to 3. And I ask you to solve for x. If you want to solve for x, that means you want x on one side and everyone else on the other side. So that means I will take the positive 1 and throw it across and it becomes negative 1. So, and 3 minus 1 is 2. Something very basic in maths you need to remember. Anytime you want to solve for a certain letter, it could be x, it could be y, it could be a, it could be b, you try to get that letter on one side by itself. And then you throw across everything. But when you throw across something, it always becomes the opposite. Why should it be any different for a complicated case like this? We want to solve for x and y. So that means we should try to keep what alone on this side, x and y, because we're solving for y. X and Y, sorry. Which means everything else, like this big 2 by 2 matrix, we should throw it across on the other side. But when we throw across a matrix, or anything in maths, when we throw it across the equal sign, it would become the opposite. In my previous video, I showed you how to find the inverse of a matrix. It just so happens the opposite of positive is negative. The opposite of multiply is divide. The opposite of a matrix is its inverse. So if you haven't looked at the previous video on how to find the inverse of a matrix, do so now and then come back to this video. So we plan to take this whole matrix and throw it across on the other side. But be very careful when you're throwing across any matrix. When you're throwing across a matrix, it has to jump over exactly one matrix. So if you're taking this matrix and we're throwing it across, it can either land here and push this around to make space, or we can throw it quite here. Where is the correct place to throw it? Here, in between the equal sign and this, or over here? Remember, I told you it has to jump across exactly one matrix. If we throw it here, that means it jumped across 2 matrices. It can only jump across one. So when we throw it across, it will jump across him and land in between here and push this 47 and 19 around to make space. So, well, on the side, like I said, when we throw it across, it will become the opposite or the inverse. So what I'm going to do, I'm going to use over here to find the inverse of this matrix. So I put a little block here and call it scrapbooking. Alright? Excuse 1 second, I just want to make sure the camera is still on. Still on. Alright. So we're going to find the inverse of this matrix. Remember, the first step of finding the inverse of any matrix is to find the determinant. To find the determinant, we multiply this diagonal first. 4 multiplied by minus 1 is minus 4. As soon as we multiply that matrix, we must put a minus signs. We have to. And then we multiply the other diagonal. 3 multiplied by 3 is 9. So minus 4 minus 9 is minus 13. To find the inverse, we take the determinant, we throw it underneath a 1, and then the main diagonal or the leading diagonal, we switch their positions. So the minus 1 will go here and the 4 will go here. We switch their positions. The other diagonal, the less important diagonal, we do not actually move them. We just make them the opposite. The opposite of a positive is a negative. The opposite of a positive is a negative. This here is the inverse of that matrix. In other words, this is the opposite of this. Both of them are opposites. So when we take this matrix and throw it across, remember, it will push around the 47 and the 19. And when this lands here, it will change to the inverse, which is this guy. So let me write this guy here. 1 divided by minus 13, with a big pair of brackets, minus 1, minus 3, minus 3, and 4. And don't forget the x and the y. Remember, we're solving for x and y, so we want x and y on this side and everyone else on the other side. How do we multiply this situation up? Remember the minus 1 and minus 13, just ignore it temporarily. So we're going to multiply a 2 by 2 by a 2 by 1. Remember the procedure? The 19 would swing up to the top. These two numbers would walk across. And we will also photocopy them over here. And we're going to multiply each pair of numbers. Now these numbers are kind of big, so I'm going to use my calculator. Let's multiply these two. Let's clear some space here. Clear the clutter. 47 multiplied by minus 1 is minus 47. 19 multiplied by 3 minus is minus 57. 47 multiplied by negative 3 is minus 141. And 19 multiplied by 4 is 76. So, when we multiply this by this, we're going to get two answers. The answer on top, we have to add the two answers on top. So, minus 47 plus minus 57 will give me minus 104. To get the number underneath, we add the two answers we got underneath. Negative 141 plus 76 is minus 65. But remember, we were ignoring the 1 and minus 13. 1 and minus 13, sorry. All we have to do is multiply each number inside here by 1 over minus 13, right? Which is the same thing as dividing both of them by minus 13. So, if we do that, if we take the 104 negative and divide it by 13 minus, we will get 8. And the underneath now, minus 65 divided by minus 13 is positive 5. The top value is your x solution, and your underneath value is your y solution. This is how you solve a simultaneous equation using matrices. I just want to show you one thing. Suppose, just a separate question just in case. I won't do back the whole question, but I just want to show you a trick. A trick question. Suppose you were given this pair of simultaneous equations. So this is equation 1, and this is equation 2. And they had asked you to solve that pair of simultaneous equations using matrices. You notice the problem with this question. The x comes before the y, but the number without the letter is supposed to be on the other side. And underneath, the y comes before the x. So before we actually try to solve it using simultaneous equations, I think I'll need to rearrange this so the x comes before the y. So this equation will change to, we have to rearrange it so that the numbers on the other side, throw across the minus 26, you will get positive 26. And this here, we need to rearrange it. We need to put the x first and then the y. So the positive 3x will come first, then the minus 2y. Well, the 7 is already on the other side. Only when we rearrange it properly and the x's come first, then the y's, and then everything else, then we can extract the numbers and solve it using matrices. So, I hope this was helpful, and of course, if you need more information on videos or extra lessons in Trinidad and Tobago, or even crash courses, feel free to check the website below, and don't forget to subscribe, share the link. Thank you, have a good day.